Okay, I make it 3 o'clock, so welcome to this session. I start the clock. Good afternoon, friends and colleagues. If I can ask everybody to take their seats, and whilst you do so, I will, in the interest of time, kickstart this session. First, let me introduce myself. My name is Nicola Marsh. I'm the moderator of this session. I work at SINTEF Energy Research, and I'm the Centre Manager for NCCS. NCCS is one of the FMEs that have come together to organise this event for you today. So together with Hydrogeni and HyValue, we've put together a session with a programme of talks to address the role of CCS and hydrogen in the short and the long term. In building the programme for today, we've invited collaborators and partners from the large and broad partnership from the 3 FMEs to share the floor with us. In doing so, we aim to highlight the challenges, but also importantly have focus on and discuss the solutions we are working towards to develop together for CCS and hydrogen. You see the programme on the screen here. So we will have an introduction first, and then 2 thematic sessions to discuss first CCS and then hydrogen before we break into a discussion panel-style debate. So, without further ado, I would like to start our session by inviting Nils Røkke to the stage. Nils is Executive Vice President of Sustainability in SINTEF and the Centre Director for Hydrogeni, and Nils will set the scene for this session. The floor is yours, Nils.
So, thank you, Nicola. Great to see so many people here towards the end of the day, although we are going to keep on until 5, 6, I guess, in its totality, and this session not. So I was asked to give an introduction, like a pitch on what we're going to talk about in this session, which is focusing on hydrogen and CCS. I think it's interesting to look at this curve, which is the curve for the developed economies in the world and how the emissions have developed over time, and then the kind of wish curve. This is where we are heading towards the net zero by 2050. And well, net zero means that you have gross emissions and you have those which we are removing. And in many ways, we're talking about reducing, removing, and then to buy time. I'm not going to dwell too much into this buy time, but then we enter into uncharted territory, because then we're starting to talk about technologies which will manage the energy balance of the Earth, like, for instance, well, it's called geoengineering and solar radiation management and so forth. Today we're going to focus here on those which are needed to both reduce and then to remove. And removal, well, that of course implies that you need to have to store this in a sensible way. And if you look to the gross emissions, what can we do about this? You probably heard that before today, but the energy efficiency, or the first of fuel, as is used by the IEA, very nice designation for that, I think. It's something we need to speed up on, scale up on clean energy supplies. I mean, there is the obvious wind, solar. Also talked about biofuels in the last session here, and then to decarbonize, which is CCS, obviously, to do that, and also use then hydrogen or electrification instead of unabated fossil fuels. And then when you go to removals, there is the natural removals, and you have the engineered solutions. And if you look to that curve again, well, this is how we envisage that CCS and hydrogen will take shares of the emission reductions. And those numbers you see here, they are from the IEA Net Zero 2050 report on the role of CCUS and the role of hydrogen in that sense. And the role of hydrogen was actually larger than that if you look to also derivatives of hydrogen, and it was also discussed in the last session about these synthetic fuels and so forth, which, for instance, by the new reporting on the carbon management strategy from the Commission is talking about a lot of these kind of synthetic fuels, which of course relies upon a system which is sustainable and with a solid LCA that is actually gains something in the terms of the climate issue. And if you look to, these curves, I'm really enthusiastic when I look to the industrial carbon management strategy from the European Commission, which now is talking about 50 million tons in 2030, 280 in 2040, 450 million tons in 2050. And bearing in mind that we've been around 1 to 1.7 million ton in Europe since 1996 or something. And all those plants are actually in Norway. So it's quite a tall order, you could say, this scale up. But it also says, well, it's according to science. Well, this is actually what you need to do. So finally, you've done the maths on these kind of solutions. We need them at scale, and at the scale we haven't really, is unprecedented to talk about this scale. Although we, of course, know from the research and academies which are working on this, we know that these figures are going to be very high to reach those targets. Hydrogen has also been a large discussion about what role it can play in the society. The Norwegian hydrogen strategy said that this is going to be important for the areas where Norway has specific benefits or specific conditions for hydrogen production and export. So it's hydrogen in, for, and from Norway, so to speak. And then to look at the production, the transport and storage, and then the utilization, and not in all sectors, but in particular to the maritime sector and to industry. So the hard-to-abate sectors, which is also part of the CCS merit. So it kind of interlinks, and it interlinks very much in terms of hydrogen based on natural gas with CCS. We know that hydrogen can be produced by different means, and often I hear that people are angry with the EU, that EU is putting very little effort in terms of hydrogen produced from natural gas with CCS. Nobody should be surprised about this. I mean, if you don't have the resource, you wouldn't use it to produce hydrogen from either. So it's not strange at all that EU has a strong focus on renewable hydrogen, because there are also big plans there for renewable hydrogen production and renewable energy. Well, the kind of envelope for this session and this day is the Research Center for Environmental Friendly Energy. And what are they? Well, we're working together with industry, with the public support. And boy, I mean, these kind of centers, which are the backbone of this session, they really mobilized industry towards these larger topics. And I'm often saying that, well, finally, it looks like we are working on the right things and not on stupid things. Because I've been working in stupid things now for 25 years, you know. But now these are the issues you really need. And I usually used to tell this story when I worked in Rolls-Royce, and I was going to SINTEF to work with CCS and gas turbine cycles with CO2 capture. It was said in my farewell party, you know, so Nils is going to do the silly cycles. Well, they are not silly anymore. You know, this is the backbone of what we need to introduce to reach these targets. So this shows the way on how we're working in these centers, and the approach for scaling up is really also to build upon research and innovation as the pillar of these activities. And we'll have a panel later on. We'll also touch into the research and the structure on how this will fit. I really like this view graph, which is from the long-term competitiveness communication from the Commission last year about sustainable competitiveness. It's such a nice word, isn't it? I mean, this is something we would like to go forward with. And if you look to what is in the center here, you see all the topics which have been part of this conference and still is. But look at all the elements which is surrounding this. I mean, a functional single market. Yeah, well, it applies to Norway as well. I mean, we're part of the internal market, but I mean, with some exceptions. The access to private capital, public investment infrastructure, research and innovation. Yes, it's going to be key, to make this happen. Energy, obviously. Circularity, well, it's also been part of this conference. So important because we need to have a realism in how we're going to use all the materials and so forth. Education and skills, well, this is something I think should be on everybody's bedroom or something. Well, I don't have it myself, but at least it's on my table beside my bed. So this is then the 3 centers which are hosting this event with NCCS, Hydrogeni, which I'm heading myself, and HyValue, which we'll hear from later on. And you see what kind of portfolio we have here. So it's going to be quite a round-off here of what is happening, and just look at the capacity building with that in mind in terms of the different elements filling in the picture for the FMEs and the impact which is creating. I'd be bold to say that from a Norwegian perspective, a European perspective, without these FMEs, you wouldn't have seen the status we have for these topics we're going to discuss today and the progress we see. So with that, I'll give the word back to Nicola. Thank you.
Thank you, Nils, for putting the FME's work into context of net zero, which is ultimately what we're all aiming for. So let's get stuck into the first of our 2 thematic sessions today, which focuses on CCS, specifically how to achieve CCS at gigaton scale. In this session, we've invited 3 speakers to the stage to pitch a presentation and from their perspective on the topic, and our first speaker is Frank Wettland. Frank is a project manager from Altera Infrastructure working on the Stella Maris project. Frank, the floor is yours.
Thank you, and thanks for giving me the opportunity to present Stella Maris CCS, which is establishing as a carbon management company, developing a full value chain for CCS. My background is I've been in the oil and gas business now for 40 years. So now I spent 35 of them polluting, and now I'm trying to do this last year's making it good again. So that's my sort of basis for being here. The Altera company, former TK Offshore, has our background from production of oil and gas on FPSOs and shuttling it to shore with shuttle tankers. So when we entered into this upcoming market of CCS, we said that, well, instead of producing oil and gas offshore and shuttling it to shore, we can as well pick up major volumes of liquid CO2 on large shuttle tankers, transport it directly offshore for injection. And that's what we have done. We have been working on this since early 2019 and have now a established concept for the full value chain, where we have on the downstream end a reservoir, Havstjerne, together with Wintershall Dea. We were granted that one in around Easter time last year, and it's under development now. We are going to drill an appraisal well in this reservoir around Christmas time this year. And the total schedule for our development of the field and the concept is to be in operation by end of 28. So it's not more time than we need to to have the individual assets here produced. We said we are going to cover the full value chain because we think that's necessary in order to get the market going. Because there is no market, and as we did, or as the oil companies did back in the 70s in Norway, they had their production facilities, they had their own shuttle tankers, they had their own onshore facilities, they had their own transport of fuel to the gas stations, and they had their own gas stations. So they controlled the whole value chain in order to make that market work. It's different today, and we think this market might also be different within some 20, 30 years. But for starting it up, we think we need to at least establish the full value chain in order to make it going. It's about large scale, and in order to facilitate large scale, we have included into this concept a receiving terminal, which might be a floating barge, or it can certainly be built on land if there are space. But it facilitates the possibility of minor emitters to be part of a large-scale value chain and get the advantage of the large-scale contracts to get relatively low prices on the cost per ton CO2 injected. So it's all about making a sort of large-scale frame contract where you only pay for the CO2 you put into it and not for the whole value chain. It's like when I take the bus to work, I pay my own ticket, I don't pay for the whole bus. So that's also the principle we're putting in as a basis here. I said we go large scale. When we started in 2019, the Northern Light project was already established. There were the Acorn project in Scotland. It was our Portos project in the Netherlands. So they were all a couple of years ahead of us based on pipeline solutions, relatively low capacities. So we said we don't want to go into sort of what they have done. We aim for the 10 years coming after that. So we aimed at sort of the interval between 2025 and 2035, and so that's where we are going to sort of get going. And we said that about 10 million tons per annum as injected volume was a large scale at that time. So we have developed a concept which is scalable, it's flexible, we can copy it wherever we want, and we can multiply the capacity. So the shuttle tankers we have standardized on has a capacity of about 50,000 cubes of liquid CO2. And going large scale, according to both SINTEF and a lot of other research institutes, it's about going low pressure and low temperature in the cargo. So we are operating on 6.5 bar G and minus 48 degrees during transport. But we are trying to standardize on these vessels so that we have a fleet of vessels and have the so-called cargo contracts like we have in the shuttle business, where the emitter only pays for what he puts in. So these vessels can go pick up CO2 from multiple places at shore and deliver to multiple offshore injection sites. Entering the offshore site, we have a floating, or in the generic concept, it's a floating injection unit, which is actually just a floating pumping station, where we have the injection pumps and the heaters required to take the CO2 from the cargo spec of 6.5 bar and minus 48 degrees up to whatever we need on the wellhead, which for Havstjerne is around 1 to 2 degrees centigrades and from 100 to 150 bar pressure. So that's the function of the pumping station, to get that wellhead pressure, use seawater as heating medium to get the required temperature. The injection unit is normally unmanned. It's as simple as possible. We don't have any power production on board. We don't have power from shore. We take the power from the shuttle tanker. Because when the shuttle tanker is connected to the floating buoy here, it's actually in principle anchored, so it has a spare capacity of power. We use that power to run the injection unit. And it's based on the principle of continuous injection, so we need to have one tanker at the site at all times. Summarizing these principles, we need to go large scale, and in order to meet this upcoming market, it needs to be a flexible concept so that we can pick up from multiple places. It can be multiplied in size, facilitate the clustering of emitters, standardized shuttle tankers, the remotely operated unit offshore, and independent of location worldwide. So we are discussing this in multiple locations. The large-scale concept, the gigatonne CCS, is sort of what it takes in order to get the market going, and hopefully the upcoming FME of the Giga CCS will help us sort of make the grounds for all of this. Thank you.
So thank you very much, Frank. And in NCCS, we collaborate on one of our 13 KSPs with Altera Infrastructure in the COFFA project, which looks at exactly this, maritime transport and injection of CO2. We have time for one very quick question. Does anyone have a question for Frank? And I will do this to see the audience. Yes, at the back. There's a hand waving at the very back.
Yes, so my name is Geir Brekke. I wonder, can you tell me a little bit about this bus ticket? What is the price of the bus ticket for each ton of CO2, liquid CO2?
Did you ask what kind of cost we will have to the emitter?
Yeah.
So it will certainly depend on the business case. But for a full 10 million ton scenario, we have said that we will easily be around 50 to 60 euros per ton, all inclusive. So, meaning if the emitters are supported by their local authorities to do the capturing part, we will make a profitable business case on the rest of the value chain. So we are always aiming at delivering a cheaper service than the ETS price. So it shall be profitable for the emitters to deliver the CO2 to us. But it's all about size, it's all about volume. So that's the reason why we have included the collection terminal to facilitate that possibility to get those large volumes into one value chain.
Thank you very much, Frank. Thank you for your presentation.
Thank you.
Thanks. So next up onto the stage, representing the storage end of the value chain, is Philip Ringrose. Philip is a professor in energy transition geoscience at NTNU, and Philip is the scientific committee lead in NCCS. The floor is yours, Philip.
Hopefully get some slides up. Thank you for the invitation. There we go. There's my subsurface dog. I'm going to complement the previous talk, which is on the transportation of CO2 from the capture sites to the store, to what happens under the surface. And this question I do get a lot is it really going to be possible, this gigaton, in the rocks? And the simple answer, which I'll give you pretty quickly, is, are there enough rock formations? Overwhelmingly enough. And I'll show you how that is the case. What about pressure injectivity? We just heard about 150 bars wellhead pressure. What's going to happen in the reservoir? There are many questions to address, but I would say that they're manageable, and I'll give you a little pitch on that one. And then something that the public is very concerned about. When we put all this CO2 underground, will it create earthquakes like we witnessed in Oklahoma or the Netherlands associated with oil and gas activities? What will happen with CO2? Yes, there will be minor tremors. We know that when you push any fluid into rocks, there are creaks, but there will be very low levels of seismicity, and I'll show you how we're planning to control that for the Northern Lights project. And then there's many uncertainties. The subsurface is unpredictable, and the way we're going to handle that, we argue, is by what I call smart, cost-effective monitoring systems. And then finally, is our society going to allow this activity to happen? And that's where I'm really uncertain, and I'll show you why I'm uncertain about that. So just quickly on the technology, we published a paper in 2019 on the global storage resources offshore. And the map here shows you the world sedimentary basins using gravity data. Red is 5 kilometers thick, and orange is 2 kilometers thick. So basically, our world and our continents are surrounded by huge, thick packages of sediments, which have housed some oil and gas and have enormous capacity. I could also make a map for basalts. There's enormous basalt resources. So there's no doubt there's enough rocks in the earth to do the storage. And we also calculated in terms of wells that to get to the 2-degree scenario using the IEA projections for storage needs by 2050, we would need about 12,000 wells by 2050. And we had an incremental growth for that well rate. And you could ask yourself, how many wells do we drill for oil and gas? Well, it's about 50,000 wells per year currently. So this is a tiny fraction of the oil and gas industry, and this is cumulative to 2050. So really, there's not a problem with the availability of the resources. We just have to drill those wells and access those resources. What about all this pressure? Now, this is the subject that really is occupying the technical people in the subsurface, and it's a bit like a party. Everybody wants to blow balloons, and in the North Sea, we have about 7 or 8 projects, all wanting to put CO2 into the ground. How is that going to work? And how is the inflations related to CO2 storage going to be connected to the deflations related to oil and gas activities? And it is a challenge, but it's basically an exciting technical challenge. I won't go into it now, but it's where we can use a lot of modeling, understanding pressure injectivity, and it's an arena where we can use artificial intelligence and human intelligence to wisely use our subsurface resources. So I would say this is a manageable but interesting problem. A good topic for the next FME. What about earthquakes? Well, I've been associated with the Northern Lights project in my previous job at Equinor. And this project we've just finished, which is preparing Northern Lights for understanding seismicity around the site. You see there the Northern Lights exploration license near the Troll gas field. And that's our earthquake listening array. And with many partners, including the Northern Lights joint venture, the industry partners, and Gassnova Climate, we've developed an understanding of natural seismicity, mainly to disassociate ourselves from false accusations of earthquakes. If Northern Lights starts injecting in the 4th quarter of this year, and suddenly there's a natural earthquake 10 miles away, 10 kilometers away, that could be serious for the project, even though it's nothing to do with the project. So that's what we call false association with natural tectonic events. And we've developed what's called the Gutenberg-Richter plot, which is how many earthquakes occur in this region due to natural processes. And we already know that on the west coast of Norway, they regularly feel earthquakes of magnitude 3 to 4. And every now and then, they feel magnitude 4 to 5, quite significant events. And we want to understand that natural seismicity to make sure that we don't have a false association. In the United States, there's also a project called Decatur where they've measured induced seismicity for a real injection project onshore United States. So this is not Northern Lights, but it shows you the type of induced seismicity that could occur at Northern Lights. It's order of magnitude lower than natural seismicity, and we want to put it in a detection system good enough to track that. So in a way, what we're doing is we're preparing Northern Lights for avoiding problems with earthquakes, we hope. So that's the technical approach to the problem, and I've only got 1 minute left. So the final problem is the sociological one, and you might think CCS is like this. It is technically. We could definitely do gigaton CCS. The problem really is sociological. Our society doesn't value CCS. They think it's too expensive. There is a lot of public criticism of it. The permitting process is not very smooth, and yet the positives are really good. CCS is absolutely essential for decarbonizing our world. It can support multiple technologies, including industrial capture, carbon removal, and fossil fuel capture. And actually, the costs are coming down. So there's lots of positives, but our society doesn't value them well enough, especially the cost. So we need to get to the point where the value of CCS is appreciated. And the costs at about, say, 150 or 200 euros per ton are very affordable, and those costs will be coming down. Thank you.
Thank you, Philip, for that. And I have a question I will take on behalf of the audience. I think this is of interest to many. So Norway has currently awarded 7 CO2 licenses, and there's 2 currently up for grabs on open license award. Terje Aasland, our Norway's energy minister, has stated that we will be ready with 50 million tons of storage capacity by 2030. What do you think it will take? Can we actually get enough licenses and enough storage capacity tested with those wells in the next 6 years to prove up that 50 million tons?
You know, and the timing of that is critical. You know, to get to 50 million tons, you need less than 50 wells in operation by 2030. Okay, so that's 6 years away. Northern Lights took about 4 years from maturation to FID, and then another 4 years to construction and first injection. So that's 8 years lead time. We could probably get that down to 5 or 6, but each of those projects needs to start now if they're going to be injecting those volumes by 2030. So that's the message back to the politicians. Make the promises, but you need to start now.
Yeah, absolutely. Thank you very much, Philip. Give Philip a hand. Thank you. All right, our next speaker onto the stage is Gunhild Reigstad. Gunhild is a senior researcher at SINTEF and with experience working on both CCS and hydrogen. And Gunhild will talk to us about the Green Shift project.
Thank you very much. So what I will talk about today is from a slightly different angle and perspective than the kind of the technical. I'll talk about the European collaboration and that this is a central part in achieving CCS at the gigaton scale, at least kind of within the European context, so to say. Of course, CCS must be applied worldwide, as we've already seen. So what is European collaboration about? Well, it's about having common targets. It's about having a shared view of the next steps. So as we just saw, we need to value CCS in the same way, and we need to agree on what are the next important steps for realizing CCS chains at scale in Europe. We need to share the knowledge, we need to all understand the potential, and also kind of the hurdles and also the challenges. And we need to build trust because, I mean, CCS is a value chain. So we need all stakeholders, including the public, to build a trust in each other and see kind of a common view of what this could be. So I have had the honor of leading a project called Green Shift. And we have, me and my team have had the opportunity to work together with the Norwegian Ministry of Foreign Affairs and the embassies in Germany, Belgium, Netherlands, and Denmark on setting up events for knowledge sharing and collaboration in these 4 countries. And we have done so on the shoulders of FMEs and SFIs, so concretely the Smart Maritime SFI and the NCCS North Wind and Hydrogeni FMIs. So these are the platforms that we needed to go out into Europe and create events and to discuss with the people there what are the common, what is our views on these technologies and what are the crucial next steps. So as you can see, we had the opportunity of having events on CCS, on offshore wind, and also on green shipping. And we focused on knowledge sharing first and foremost, and there we stand heavily on the FMEs and also the European projects that we run. We looked for European solutions, including for the policy framework, and we invited also Norwegian industry into these events to build collaboration and trust in a European setting. We did something else too. We put the emphasis on bringing all these 3 stakeholders into the same room from all the 5 countries. So the businesses, the governments, and the research. And you've already seen this one once before today, and that's not by coincidence. So this is an important part of having a transition that is fast enough. We need all these stakeholders to be aligned, and they need to talk so that we know what we're about to do. So a few words about the concrete events, and I'll focus on 2 of them. So the first event is the CCS event that was held in Düsseldorf. It was a very interesting event. I think we had a lot of, how can you say, local industry from the North Rhine-Westphalia area in Germany. Industry actors saying that we have CO2 emissions as part of our industry processes. CCS is the only solution, and we need to see now that there are plans for establishing pipelines so that we know that the transition will be possible for us. Out of this event, 5 key recommendations were delivered and signed by quite a few of the participants at the event. And of course, these recommendations have their focus point on the strategy for CCS, which we this year has gotten, and which is a great step forward for appreciating CCS and also realizing these technologies in Europe. And then this final event was held in Brussels. We were able to have both the Norwegian Minister of Energy, Terje Aasland, and also the Belgian Minister of Energy, Tine van der Straten, at the event. And we lifted the importance and the role of research and innovation in strengthening the European industry and their competitiveness, and in securing efficient realization of the infrastructures that we need for decarbonization. And we also dived into the potential for increasing the multilateral research and innovation collaboration across Europe, and how this can be done to go beyond the traditional European research programs that we see today. And that it is important to seek teams of willing among the countries to be sure that we can have projects with the people at the forefront, that they can spearhead even faster and bring the technologies faster to scale.
Thank you so much, Gunhild, not least emphasizing important strategy documents like the Industrial Carbon Management Strategy. So keeping up with Europe is a challenge that we have. I want to ask you, how do you think a concept like Green Shift can support then the gigatons, the scaling up of CCS?
I think it's important that we continue to go out and meet people where they are. It's a lot easier to kind of get a local anchorage if you establish a meeting place close to where they are. And I mean, this event that we did now was kind of the first round off, and we had a quite broad topic. But I think it would also be highly valuable to go down and narrow down the scope and be even more concrete, and to bring all these people into the same room and to discuss the questions together.
Agree. Power of collaboration. Thank you, Gunhild. Thanks. Give Gunhild a hand. Thank you, everybody. So we will now change our focus from CCS and move across to hydrogen, which is represented in the room by 2 FMEs today. We have Hydrogeni and we have HyValue. So our focus in this session will be developing a robust hydrogen market at scale. Our first speaker then is Fionn Iversen, according to the order of the slides. Fionn is the Center Director of HyValue from NOS. Feel welcome to the stage.
Thank you, Nicola. Yes, indeed. This session is based on collaboration between Hydrogeni, HyValue, and NCCS. And we need collaboration between those centers. We need a link. We need rapid implementation of solutions for meeting the greenhouse gas emission goals. And indeed, hydrogen and CCS will contribute to this. So how can we achieve this? And how can we achieve good international collaboration? So with respect to export, as already discussed, research and development, and of course, industrial collaboration for implementation. Norway and the US has bilateral collaboration on CCS. This was extended to hydrogen at the meeting last year in Washington, DC. So US see it in the same way. There's a close link. We need to see these matched. This is, of course, related to blue hydrogen, as we've already heard about. And also, of course, the thinking behind joining the 3 FMEs in this session. We can switch to the next slide. Maybe I can do it myself. There we go. However, this is not in line with EU and EC thinking. As Nils Røkke previously said, there isn't really an understanding for this. They don't have the resources that we have with respect to natural gas, which we can build on. Okay. So there's a challenge for blue and also other production methods based on non-renewable, i.e. Use of natural gas for production. So there's a disconnect between hydrogen and CCS. They need to be seen together. Again, Nils Røkke and myself are contributing on behalf of the Research Council and the Norwegian Ministry of Energy in work under the SET plan in a temporary work group for hydrogen, which will become an implementation work group, which will again help with implementing the research plan of the Strategic Energy Technology Plan. Here there is a discussion with respect to renewable, low carbon, and how one should prioritize. And these are the 2 terms that are defined by the EU, i.e. renewable, meaning production from only renewable resources, including the feedstock, so not natural gas. Low carbon is part of this. So it's a discussion which is ongoing, which is very important, and which we are taking part in. At the same time, we are discussing with authorities in other countries. We had a visit this week, actually, from the authorities of the Netherlands. So the Finance Ministry and the Ministry, the Environmental Industry. No, sorry, the Ministry of Environment. They visited our Ministry of Energy the day after. Such dialogue is very important to communicate the understanding of what is needed. So, two, we need rapid change. We need solutions for reducing the cost for production. Traditional green hydrogen is costly, and we can look at it very simply. The energy in the binding of the water molecule is a lot stronger than the chemical energy of the methane molecule, meaning that you're fighting this from the start. So that's unavoidable. So you will need a lot more energy producing from electrolysis than using steam methane reforming and doing blue hydrogen. Okay. So we need this for sustainable business models in the short term. We need to choose the solutions that are energy efficient, i.e. blue and other production methods, whilst for the long term we're looking at green hydrogen. Now, hydrogen valleys are meant to facilitate implementation of hydrogen, large scale. But they're only focusing on renewable, so green hydrogen, again. So we need discussions with authorities nationally. We need to communicate the understanding of the best solutions with respect to reducing greenhouse gas emissions, and further build on this for implementation. So this is one of the central work. Yes, we need to do the research. We need to generate the understanding for this. We need to find new solutions to build more efficient production methods. And then we need to communicate this, get an understanding for it, work together with the whole of Europe to implement these solutions. So short term, look at efficient production methods from natural gas. Long term, indeed, we will generate more electricity towards 2050. There will be implementation of wind, there will be implementation of hydrogen. Then we're looking at green. So that's my message. We need to communicate this. We need to have collaboration of this to be able to implement in the short term and meet our goals for 2030, while we're also working on implementing solutions for generating power for the 2050 goals with green. Thank you.
Thank you, Fionn. And you mentioned implementation a number of times, so I'd ask you a question about implementation of hydrogen. What will it take to implement the hydrogen value chain?
Indeed. So I've talked about it a lot. Indeed, the most challenging is the business case. So the production cost is very, very high. We can't solve it through taxes and subsidies in the long term. Taxation will result in higher energy prices. So also for hydrogen. So that means that it becomes more expensive for everyone. So we need to find solutions which are sustainable in the long term and avoid too costly results for this. In this way, it can become sustainable. And one of the key areas is reducing cost for production, i.e. production efficiency.
Very good. Thank you.
Okay.
Thanks. So next up onto the stage, we have Ingo Markenbach. Ingo is a head advisor for new energy solutions in hydrogen at Statkraft.
Yes, thank you very much, Nicola. Good afternoon, ladies and gentlemen. Thank you for having me. I will be doing something here today that I normally don't do. I'm not presenting my own work. I'm presenting the work that has been done in Statkraft's strategy department. We have a low emission scenario that was published in 2023. This is modeling work. This is really a large report. You can download it from Statkraft's website. There's no time to go into this in detail, but I've just tried to extract the information relevant for hydrogen from it. And as Statkraft is supporting both HyValue and Hydrogeni, this is also a little bit of a backdrop why Statkraft is going into hydrogen. So in this scenario modeling, we have had a low emission scenario for a while. This is a bit of an optimistic view on the future, so we don't really see a lot of obstacles. You assume a certain energy mix in the future, and then you start working your way towards 2050. You see that a lot of all the fossil hydrogen will be replaced with clean hydrogen, and you will end up with a fairly large share of hydrogen making up the global 9% of the final global energy demand by 2050. But we have recently then also looked at other scenarios. So taking a little bit more these social science into consideration, we have a clean tech rivalry scenario that really looks at a little bit the competition between different technologies. Subsidy-fueled competition, also geopolitically fueled, because you get these kind of competitions between China, Europe, United States. We also consider then diminished incentives because you do not have that carbon pricing mechanism in place that you wish, ref the cost debate. But what we see in that is that we get a slower start in the transition, but then an accelerated or exponential growth, and actually then surpassing the investments compared to the low emission scenario. And then we have a bit of a more pessimistic, it's not a real worst case, but it's a pessimistic view that is also relevant for hydrogen. And of course, in a scenario where you don't have the political initiatives to keep the investments up, you don't have the renewable capacity addition that you need particularly for green hydrogen production. You have largely an absent infrastructure for hydrogen. And then you also have international standards and regulations not being in place, so that's also hindering the transition. So just quickly on the estimated primary energy use, going from today and then into the future, the scenarios are quite different here. In a low emission scenario, we would like to see that the primary energy consumption worldwide will go down. We're phasing out coal a lot. We're phasing out oil and gas. And we get large capacity additions on the renewable side. The clean tech rivalry scenario will end up only a slightly lower primary energy use, because you still keep some of the fossil capacity in it. But you also have large capacity addition on the renewable side. And then in the delayed transition, you basically have the same oil and gas consumption as you have today, except that you've phased out coal. So what does it mean for CO2 emissions? Up until 2030, you can debate back and forth, but it's just a couple of years from now. So you will see just minor reductions or even some increases in the CO2 emissions. But then in 2050, you see that the first two scenarios, they will actually give you significantly reduced CO2 reductions, whereas the late transition is really the scenario where you fail also to meet the IPCC targets on global warming. So the transport sector, we've been looking at this in the previous session, and this is also a bit in line with what Antrans and the other FMEs have been presenting. So the energy use in transport, we foresee that in the cleantech rivalry and in the low emission scenario, that we phase out a lot of oil out of our transport system. We're replacing that with electrification. And you also see hydrogen coming up there, a significant share of hydrogen used in those scenarios. In the delayed transition, not so much. You have oil still being dominant in the transport sector. And you see some of the growth has happened on the renewable side, but not so much hydrogen. So hydrogen in the hard-to-abate sectors, you do see here, the whole point here to show you is that even if you assume the more pessimistic scenario, you will get also hydrogen in the hard-to-abate sectors. So there is, and it's a significant share compared to what it is today. But in the low emission scenarios or in the cleantech rivalry, we get significant hydrogen use in the hard-to-abate sectors, particularly in industry. We see the European landscape a little different than the rest of the world. We do believe that there is a different policy making in place. So preferably, we would like to see things happening very quickly from 2030 to 2040. Whereas if we don't get that, if we get hurdles, then we may end up with a somewhat slower transition. But you do see that we have a significant use of hydrogen in the industry and in the transport sector primarily. So you may want to ask me, well, what about the current picture? Because do things really look that good? Now, the scenario modeling is normally not affected by the status quo or what is happening right now and today, but there are things that can have an effect on the future modeling, because we do see that security and particularly defense spending is going up many places in Europe and also in the world. These are funds that are being locked up in everything else but energy transition, so that can potentially slow down the transition. We also see industry competitiveness higher on the agenda in Europe. Cost increases is probably in everyone's mouth these days. Offshore wind has been discussed previously today, but we see that also for hydrogen projects. I may want to rephrase that. Not all of the cost increases that we've heard about in 2023 are real cost increases. Part of that is inflation related, yes, but there's also a lot of so-called cost increases which aren't really cost increases, but they're based on the fact that we simply haven't built particularly green hydrogen projects for a long time, and a lot of the projects are at low maturity. Meaning that your cost estimates have a large uncertainty, and you're only now bringing the engineering forward, and you see your real cost estimates, and they're coming out higher. Make also no mistake, management consulting has been underestimating the cost of green hydrogen for many years now, and they still do. So there's also a factor there. We do see signs of slower transition in some of the end-use sectors. Particularly, I want to highlight industry, chemical industry. Take Germany, for instance. You see chemical industry struggling. Obviously difficult for them to transition if things are not going well. We also do see some resistance in some of countries, and that is a bigger problem. You see some resistance in some countries of adding additional climate policies, and they even want to roll back on certain of the sectoral targets or on phase-out dates of some of the fossil generation capacities. That is a bigger problem, because we're talking about strategic choices here that can have a 10, 15-year horizon, and that will have an effect. In the hydrogen supply chain, we see things maturing. We are spending a lot of time evaluating the green hydrogen suppliers. Things are not happening as quickly as we would like to see, but that is largely because projects are not taking investment decisions, and then the scale-up in the industry is lagging somewhat behind. But we also see interesting industry clusters forming now. There are, just 2 years ago, you would go, you buy your hydrogen here, your ammonia plant there, and you would integrate it all by yourself. You would be sitting on all the risk. What we see now, there are consortia forming. They will be offering you full-scale EPC projects, even on derivative plants. That is relatively new, which will de-risk basically the projects for us as a project owner and make it easier to implement. So in summary, we don't really see a scenario where hydrogen does not play a role. So in all of the scenarios, hydrogen plays out. You can believe in what you want, but hydrogen will be there. In the short term, and that is very much aligned with our project portfolio at the moment, the project assets will be located close to sites with high industrial activity or transportation hubs, because we don't have the infrastructure. We don't have it yet, but we believe that it will be coming. In the medium and in the long term, there are lots of different applications for hydrogen, also for green hydrogen. I'm not going to list them all up to you, but I mean, in the energy system services per se, this is something that has been also discussed previously today. There's short-term flexibility management, medium-term flexibility management. This is where hydrogen can play a role, and even in the long term, if we get the storage solutions. The speed of that transition is policy dependent, as some of you have already been in. That is clear. But our ambition is largely to go to green hydrogen here and be builders, owners, and operators of green production assets. And these ambitions remain unchanged. Thank you very much.
Thank you very much, Ingo. I would like to ask a quick question. You mentioned investment decisions in your presentation. Markets need certainty to make financial investment decisions. What do you think the market needs to be able to get to those FIDs in the hydrogen space?
Well, it's a difficult question. So what we have in place, excuse me, what we have in place are different funding mechanisms for CapEx offset. So you can go to the Innovation Fund, EU Innovation Fund, you can go to the European Hydrogen Bank, and also some European countries have such funding. That offsets your CapEx, and that brings your production costs down, but at the end of the day, that's still not enough. So you still need something else, and then we're talking probably something about contracts for difference, something to that effect, but it's very difficult for the policymakers to agree to these. But we're following very closely what's happening in this scale.
Yeah, good. Thank you so much, Ingo. Thanks. So our last speaker in this second thematic session is Per-Ove Eikeland. Per-Ove is Senior Research Fellow at the Fridtjof Nansen Institute.
Thank you, Nicola. So I'm representing HyValue. We are part of a work package focusing on the social science research, together with the technology research, of course, to have and my major partner, or the leader of my work package, is from the Norwegian School of Economics, and we cooperate also with the Institute of, or the Department of Legal Studies at the University of Bergen and TØI. The Fridtjof Nansen Institute. We work a lot on the framework conditions evolving in the larger European market, or the market to be for hydrogen, and look at the strategies of different European countries and the EU strategy and the implementation of that. So today, sorry, I will give you a snapshot of the status for development of hydrogen in Europe, of the market, and look a bit, very briefly, on the recent policy developments to implement the hydrogen strategy of Europe and the challenges, and then close off with a bit on the role of Norway in that sense. So first, a bit on the hydrogen strategy of the European Union, which has seen a development since it was first launched in 2020. Then obviously a part of the Green Deal to deliver on the 55% reduction in CO2 emissions, greenhouse emissions. So the hydrogen strategy was the first time the EU had a really short-term deployment goal for hydrogen. Coming from an R&D background, this was really about deployment. So they put up targets already for 2024, but it's like for 2030. They put up this goal to have 10 million tons of hydrogen in the energy mix. And that was to be produced domestically by the green hydrogen production line. So for consumption, in this very short term, it was a lot talking about reduce the use of grey or hydrogen and in the refining, and to kind of start out working on new consumption in industry and heavy-duty transport. For 2010, it was also, in addition, they started to talk about the market, and Ukraine and Africa, North Africa, was actually singled out as the major kind of collaborating partners. Then for 2050, they put up a goal or an expectation that hydrogen could make up 13 to 14% of the energy mix. If we go to what happened in 2022 after Ukraine was invaded by Russia and the conundrum in the energy markets, the EU reacted and they agreed, the 27 countries, to kind of accelerate the transition, also accelerate the consumption of hydrogen to 20 million tons by 2030. And then add a target for imports. And the new was the North Sea countries were also much more better integrated into that import strategy. We can also see a development now, has been mentioned with the industry strategy of Europe, the green industry strategy, that you also extend the hydrogen strategy to involve the whole value chain of electrolysis to be produced in Europe, and now also how you can provide the raw materials for production of hydrolysis and the fuel cells. And you also, of course, mentioned that carbon storage is also being part of that new industrial strategy. So a bit on the market status so far. This is built on Hydrogen in Europe. They monitor the market. So these are data collected from them. I'm going to be short here. So the status is, of course, there is capacity for hydrogen production of 11.5 million tons. And that's mostly grey today. There are many projects planned, even there were short-term products, but we see a drop in the products, withdrawn of planned products. Only a fraction of the production today is green, 0.3%. So for 2030, that means it has to be massively upscaled, 150% growth per year to reach the 10 million tons of green hydrogen. There are many planned projects, and they actually accumulate to 15.6 million tons per year, both green and blue. But only a few of them, 4.4% million tons, is really in an advanced development stage. At the consumption side, we see a decline in consumption of hydrogen, actually, from 2020 to 2022. But it's increasing in refining, though. And we also see that for 2030, the planned products are not matching up with the production. On the transmission and storage sides, we see that Belgium and Netherlands are the most advanced plans and legislation. And there are storage projects advanced in Germany, France, and Spain. And you have also the whole plan is actually presented by the gas TSOs in Europe, or that has a plan for how the hydrogen infrastructure should be developed. So this very snap on European policy as a driver that may change this a bit towards 2030. The Fit for 55 package, which was presented in 2021, and an agreement has been reached on a lot of new policies. They have reinforced demand-side measures with the EU ETS, reinforced, extended to the maritime sector, and to replace the free allocation of quotas and introduce the carbon border adjustment mechanism. And there are targets now for green hydrogen in industry and transport. At the supply side, you have reached definitions of what can qualify as green and clean hydrogen. I cannot go into that. It's very interesting. There are various EU programs established, including auctions and state aid guidelines that allow generous national support for projects. We had a seminar or webinar a month ago on the funding side of EU and Norway of hydrogen, so that can be looked up at our website. On the market infrastructure, there are also new policies in place. I'm not going into that. But despite the policies, there are numerous technological, economic, and political challenges. As I said, offtake are limited by maturity and cost of technology, threat of global competition, and internal competition between clean technologies. FID for production projects are limited by lack of FID in offtake and poor progress in construction of infrastructure. So there is a huge coordination challenge. And the funding needs is obviously a challenge. So if we go to the political side, it's been also mentioned here to guarantee the build-out of renewable energy. But there is also a challenge to agree on the public funding and how much gonna be leveraged for private funding of hydrogen. And how to share the cost between the public and private funding is a major political issue. And the latter must increase massively the private funding. So shortly on alignment between Norway and Europe, there is obviously a shared focus on developing European market for clean hydrogen. And the EU input needs matches export orientation in the Norwegian strategy. The 10E policy of the EU now includes about 60 hydrogen projects, and the pipeline from Norway to Germany is also included as a project of mutual interest. The tech projects of Norway and the funding is well aligned with important end-use sectors singled out in the EU strategy. But there is, as Fionn made his point, there is a source of misalignment. Should blue hydrogen be eligible for EU support? There may be some movement here, but there is still a lot to do on that issue. So to conclude, the EU has adopted a clean hydrogen strategy driven by climate, security, supply, and competitive concerns. The status is that many projects today are planned, but few reached FID. There are a lot of new policies likely to drive new development in clean hydrogen, and then particularly in industry, and perhaps first and foremost in refining. There are major technological, economical, and political challenges that must be addressed, and Norwegian EU strategies are aligned in division of labor, input and export, and in funding and technology development. But differing views on green versus blue production lines still a challenge for Norway to take a more active role towards establishing the European market. Thank you.
Thank you, Per Ove. I would ask, maybe we could start to get the panel ready by bringing up the tables, and our panelists, whilst I ask you a question, can be coming up to the front. So you've mentioned various policies, initiatives to do with hydrogen. How can those policies help us to make the best choices when it comes to implementation and development of hydrogen?
What kind of policies do you think? What is? Well, I guess there are policy is a lot of things. It's about coordinating. It's about mobilizing industry, and you have the seed money from the public funding is always thought of as seed money to attract and to reduce the risk of the private capital. And obviously, you don't have enough of public funds now that has attracted and sufficient to reduce the risks for private industry. But policy can be more. Obviously, if you're going to get to a European market, you need to look at the whole supply chain, of course, and you need to really coordinate policies along the supply chain, and you need to do it also geographically between, so that you kind of match all this money to make the most out of it. That is the intention of the EU, but the EU is also kind of limited by how much the member states are willing to give up kind of their power over energy policy and move it up to the EU level.
Thank you, Per Ove. Thanks. An applause for Per Ove, please. And we move now to our panel, or our closing discussion, in which Nils Røkke will come back up onto the stage and help with the moderating of the session. We will talk about mobilizing R&D and industry for realizing the potential of CCS and hydrogen.
And then the question to you, Nicola, is how much time do we have?
Not much. No, you have...
I think we've got 20 minutes.
15, 20 minutes, yeah.
I've got 20, right, thank you. So, without further ado, I'll ask the panel to enter the stage. I see Rune is over there. I see Guro is coming now. Yeah, and I also see Hege and Katrin. Great. So there you got Guro Angel Gimse, which is the regional director of NHO in Trøndelag, and Katrina is sharing the table with her. Now with Bellona, used to be SINTEF, huh?
That's right.
And Rune Wolla from the Research Council, Director at the Research Council, and Hege Rogne, which is Senior Advisor in New Energy in Equinor. So a smashing panel we got here. So I'll run this with one question, which is common to you all, then do some more targeted question. If you have time, maybe there's some interaction with the audience as well. But let's get going. And from the perspective of the sectors that you are representing, what can be done to realize the potential of hydrogen and CCS? And yeah, I give it to you, Hege, first.
Thank you, Nils. Big question. I think what we do have already is technology. We do know how to do it physically, technologically. So what's needed in many ways is the way to share the bill. And how can we share the bill for the investment, for the infrastructure, for the added cost, because there will be a huge added cost for all of us, and have to share that in the logical way is about the one big hurdle that I see.
Okay. Right. I mean, there's a lot of discussion here about the cost, but I'm sure maybe that's been discussed in other part of the conference here, but there's also social cost of carbon emissions, I think, which we need to take into account in that question. But maybe Rune then?
Yes. Yes, I think it was quite a wide question.
Yes, it is, by purpose, yeah.
Yeah. Okay. So, well, to start, I would say that we are already doing many good things in Norway on the research side, and from the government side, we feel that we think that to have these FMEs and to have these targeted efforts within hydrogen CCS is a very fruitful way to go forward. And what's unique in Norway is the collaboration between the government and the industry and the research, which should be not underestimated. And it may also be something that we can try, and we are trying to sell or to tell about to Europe, because we need to get a wider collaboration to realize this, and probably both within, as we have seen within for the industry, but also within the research. So widening the collaboration and continuing to get outside of our own country would be very important, I think.
Mm-hmm. That's useful input. From an NGO point of view, Katrine, I mean, Bellona has been very active in the EU context, especially on CCS, maybe not so much on hydrogen, but how
not
do you
yet.
see from... Sorry?
Yeah, not yet on hydrogen, but
not yet. Well, I've seen some op-eds, but anyway, I mean, what's your view, you know, from your sector, which is the NGO sector?
Well, I agree on the importance of research, but also I think we should stress the importance of actually going into action and to get building capture plants in Norway to get the experience, because then you also can accelerate the reduction of costs, but also the experience. Mm-hmm. And that also comes with the good news that you have licenses at the Norwegian continental shelf. And then you also get experience about the whole licensing system. It's based on the petroleum licensing system, but it's not exactly, when you do this copy-paste, it doesn't really fit. So you get experience and you have to see how it can be more efficiently, still safe, but also minimizing the time from you have your application until actually the license is operative. So I think we should also accelerate to getting into action, and that the Norwegian government should support more the actually large industry that now need to decarbonize.
Mm. And Guro, let me see if I get this right, from the Confederation of Norwegian Industries, huh? Mm. So you've got a big heart for large and medium-sized and small industries and companies, you know. What do you think of the industry voice towards this scaling up?
From our point of view, we think it's important to support flagships like we have heard about today. And there are lots of policy development to be done. Last week I visited Verdalskalk. And they are now attempting to realize a CCS project in cooperation with Ocean Geoloop. And this is very hard because they actually lack energy. And they are sadly in the situation that it can't be guaranteed. So one of our main goals must be to increase the production of renewable energy to succeed with also hydrogen and CCS. Also, we must increase funding for research and development. And I know that Norway relies a lot on Europe for funding. So we need to grant more money from our policymakers to research also.
That's a perfect bridge, actually, to the next question I'm going to pose to Rune. But for all of you there, you know, prepare yourself. You have some questions here for the next round. And Rune, as you painfully know, you know, the grants for research in energy and climate in Norway has been dropping the last 3 years, which is kind of strange given the urgency of the situation. There are different numbers around, but we're talking about maybe 20%, maybe more than that if you do inflation correction. And I just wondered, how can we mobilize for greater efforts into this? I mean, everybody here is touching into the importance of research and innovation as a stepping stone for getting this going, because we cannot just fill in the higher TRL range all the time. Well, I may be giving the answer now, but anyway.
No, but well, what can we do, everyone? I mean, all of us should try to talk about the fact that we hadn't been where we are today on CCS if it hadn't been for research and development. And we still need to have new generations of technology to succeed. And maybe it's like Bellona, they have been missioning for CCS in Brussels since the 90s, probably. And at the same time, we have been funding a lot of research and development to mature technology and make it possible to use. And this is a story that needs to be told. So we need to have two thoughts in our head at the same time, and to tell both about the need for research and development and the need to take the technology into use. So it's not a good answer, I know, but another thing I wanted to point out is that while the national funding has been shrinking, we actually have succeeded, or you have succeeded to get a lot of money back from the EU framework programs. And this is also important, that we continue to grow this, and also that, of course, we as funders have good ways to ensure that both you mobilize and you can have these EU projects into the portfolio, which we regard as just as valuable as the national ones.
Yeah, but I think also many people are, more money to research. I mean, what's coming out of it? I think it's really important that you bring forward what is the impact of this, what is the effect of that, and as has been said here earlier on also about the research into the innovation into CCS has made it possible to qualify the storage, and the possibility now that we see in the full-scale projects is often under-communicated in my view. Yep. What do you think about that, Hege? Do you agree with me, or?
Yeah, I do. I totally agree that, and it's also still important to continue to find the more cost-efficient solutions and to build capacity and competence for the industry, because now that we're scaling up, or hopefully scaling up dramatically, we need a lot more people into the industry, and having that capacity increase is also part of it. But I just want to make a quick comment that I totally agree with Bellona here, that we also need to focus on the moving from studying it and the desktops and the research into action, to actually reduce volumes or greenhouse gas emissions. Yeah. And then there's also a lot more that's needed.
And if for time, I'd like to come back, on your view on the hydrogen issue, because you've also been the board on Hydrogen Europe, so that's the Clean Hydrogen Partnership. Katrine, so Bellona as a warrior in Europe, and a kind of unusual NGO which has been very pro-CCS all the time,
Yes.
What do you think now about the situation in the EU, which I heard here is really changing, with volumes just go skyrocketing, and where do you see Norway being an early implementer of this? Where do you see Norway in this now?
Yes, of course, we know from history that Germany has been very skeptical to CCS, but the last year, you can see some weeks ago, they actually have the carbon management strategy. So they are looking into and seeing that actually CCS have to be a plan of part of their decarbonization plan. So I think absolutely it's moving in Europe. Also France, not just a month ago, had announced the same plan. The strange thing is that Norway doesn't have a CCS target, so that could be nice also to have for us. And I would also like to say that we are, even though I said we should do in action, there are some positive signs in Norway. Now, because on Monday, Enova will announce the 9, let's say, winners of the call they just had out for Forstudie for karbonfangst 2030. So that will be announced on Monday, and in addition, they will also have some information about the new support scheme for decarbonization. So we see that it is happening in Norway, but perhaps not quick enough in order to reach the 2030 target, but that will be. And in addition, there is also 2 reports, one on the carbon removal that arrived last Friday, that Oslo Economics that has been doing for the Miljødirektoratet. And in 1st of May, there will be the measures for CO2 management for waste incinery and industry that will become. So I guess everybody that's interested in the support scheme and what's happening in Norway should follow that closely.
Yeah, so let's bring in from that to implementation, and that's I guess the impatience that I'm feeling here. Guro, I mean NHO and LO has done some reports also on hydrogen and CCS and so forth, and there is also always a discussion about sustainability and the issue about picking winners versus being just technology neutral. Do you dare to say anything on behalf of NHO on this?
I'll have a try. In general, we say that technology neutrality is the rule. But as you pointed out, we have made a strategy on hydrogen, and we also think that CCS is a future business for Norway that can replace the incomes that we have from the oil. So in a way we are pointing, but we in general the policy is that politicians should stay away from pointing, so we kind of talk with two voices on this matter.
Okay, yeah, I guess we could entertain quite a long discussion on that, because I've seen, I mean, the EU is adopting very much targeting these kind of technologies are strategically important for us, as in the Net Zero Industrial Act, for instance. You know, it's almost like planned economy, which is a bit unusual, but we also are in very unusual times, I think. Let's see if there are any questions in the audience. Anyone raising their hands? Don't be shy. There is one. 1 minute. No, go on. Yeah, okay. Well, then, I mean, I had prepared a question for you as the last question, because I don't see any hands raised here on the way forward. But I'll rephrase it, because tomorrow I'll be in a discussion in Bergen, and being what is it called? Rapporteur, and commenting on the Minister for Environment and Climate speech. And what is the question I should ask him, do you think? I can start with Guro then.
Thank you for giving me that.
Because I'm thinking about it myself, you know. I don't know what he's going to say, but he's probably going to say something about there's going to be, you know, the pace and the targets, so 2030 versus 2040 and 50 and so forth, you know. So do we have the right policy is in place? What should be the question to the government and the representative from the ministry?
I think you should ask him, are you willing to take a part of the risk for developing hydrogen and CCS?
Oh, that's a good one, yeah. Thank you. And Hege?
Well, the other, something around when to move the focus from Scope 1 emissions, which are important, but to the really big Scope 3 and towards the net zero. You know, what's the plan for that, and when are the strategies coming out to reach the 2040 and 50?
That's two of them. And if you were the opponent tomorrow, together with Kristin Halvorsen, what would you ask them?
Well, I would probably go with the obvious questions about how to connect the development and the research for new solutions to the implementation of the ones we have.
Okay.
I mean, I think it is important when you talk to politicians to ask them if they are aware of. I mean, Norway raises a lot of money now, and you need a lot of money for implementation, but it's no use to take away the research funding to implement the solutions over the first generations. So I would ask that.
Kind of had the...
Where is the money?
Where is the money? Right, okay, yeah, I get it. And then?
I must say I agree here with the risk question, because I think that's very important, and that's what Longship, what the government is doing with the Longship, is the risk reducing, but what for the ones that follow after? And like for the storage part, there's a lot of risk related to that, but the Norwegian government have decided not to do anything. In Denmark, they have 20% ownership of the license, for instance, or in Netherlands, Portos is a governmental organization. So I think perhaps in some way that the government could be much more active and take more risk.
Okay, more active government. And the money we heard from the audience,
Yes,
and a lot of good input here. Thank you very much. I think we need to round off. I don't see any burning issues in the audience, so give a big hand to the panelists. Thank you.
So much to our panel. I would like to, I realize we're slightly over time. I want to honor our original program. So before we get thrown out the room, I would like to invite Mona Mølnvik onto the stage. Mona will round off with some closing remarks. Mona is a research director in SINTEF Energy Research and the center director for NCCS.
Hello, I am here until I'm thrown out. I have made my notes for this very comprehensive 1.5 hours talks and discussions, and it's impossible for me to do the summary in -5 minutes. And with minus, I mean less than 0. But I think we had the panel here in the end. So you said it, and I would kind of remind you what Philip Ringrose said. It's possible to do 50 million tons CO2 storage by 2050, but then we have to start today. Hege reminded us about what have been called, it's an elephant in the room, the Scope 3 emissions from the Norwegian oil and gas, or all the world's oil and gas production. We need to dive into that, and we need to talk about what to do about that from a Norwegian perspective and from a global perspective. We need to share the risks, so we need a policy in place, and the actors need to know exactly what are the rules we need to follow, and what are the what do we get and what do we have to take of risk ourselves. And we had this discussion about blue or green hydrogen and CCS, and I would like to kind of remind us that without green hydrogen, without blue hydrogen, without CCS, we will not be able to get to net zero in 2050. So let's keep up the pace and be advocating for all of this together. And by that, I really would like to thank those of you that have made this evening possible, and wish you all a very nice evening. Hope to see someone of you in the dinner tonight. And by that, thank you all very much.